Hello everyone, welcome to this video on the direction sense test. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with our e-learning partner GTCUBE Get to the Top. If you are watching this video in the YouTube channel, do check out our full-length course available for free at gtcube.com/store. So let's get started. So first, let's understand the basic directions. If you look at all the questions based on these concepts, they would be referring to the directions north, east, west, south, northeast, northwest, etc. So for us to solve the problem, we need to actually understand the directions first so that we can be consistently using the same logic to solve the questions. So the four main directions are north, east, south, and west. So you'll always start with a point and understand if person is walking towards north, it means he's walking in this direction. If the person is walking towards east, the person is walking towards this direction. If a person is walking towards west, that means the person is walking in this direction. If a person is walking towards south, the person is walking in this direction. Right? North, south, east, and west. So, what about northeast? That should be in between north and east. So, this is northeast, right? And southeast is between south and east. So, this is southeast. And southwest will be between south and west. And northwest will be between north and west. This is a standard template that we use when we are solving a question. You know, if a question talks about a person is walking towards northwest, that means we immediately think, okay, the person is starting at some point and he must be walking in this direction. And because we count this to be the north and this to be the west, so this should be the northwest. Once we understand these directions better, we can use this consistent logic to solve all the types of questions asked in this topic. So let me explain this with a couple of examples. So first, we should also understand the reference of right and left. Sometimes we might get a combination of the north-west directions and a person is walking to his right, to his left, etc. Let's look at an example. A man faces north and turns to his right and walks for 2 kilometers. So if a person is here, he is facing north, that means he is facing in this direction. To his right, that means this is right. And this is left. It should be more precise, turns 90 degrees to his right or something. Generally, even if you don't mention it, means I would take it as basically turning in this direction. Right, turns to his right and walks for 2 kilometers. So he is walking for 2 kilometers. So he started at A, he was facing north, right, you know, right, north is this direction. To right of his is this and left of his is this. A person is turned to his right, so that means he is now facing east, and then he walked for 2 kilometers, so that means he would have reached point B and he is still facing the east direction. Let's look at another statement. A man faces west, so a person is here, faces west means this, because I know west is this, right? He turns to his left, so if a person is facing to his left, to west, his right is this and his left is this. So a person turns to his left, that means he is facing now south and he walks for 2 kilometers. So he started at A, he is now reached B after he turned left. He walked for 2 kilometers. So one common set of clues is saying that a person turns to his right, turns to his left, which means, as I said, you should count that a person turned 90 degrees to his right. So a person was facing this direction, to his right he turned 90 degrees. So that is from north is changing to east. If a person was facing north and turned left, that means I assume that he is now facing west. If a person is facing south and turned right, that means a person is now facing west. Right, because this is his right and this is his left. Other element is angular movement, where I would also get to see the degrees in which the person has turned. A man faces south At this point now he is facing south, turns 90 degrees to his right. As I said, the right is this for the person facing south. So he turned 90 degrees. That means the person is now facing west and walked for 2 kilometers. If I say a person is facing south and turned 180 degrees to his right, that means the person is now, this is 180 degrees, right, to his south. So he was facing to south, so to his right. He turned 180 degrees to right. That means he turned, and now he must be facing the north. So that sometimes if I don't mention this turn to his right, by default I would take that the person would have turned towards 90 degrees. But because that is something that might get mentioned sometimes, like 180 degrees, 135 degrees, 45 degrees. For example, see this, a man faces east and turns 45 degrees in anti-clockwise, right? Anti-clockwise, clockwise is this direction, anti-clockwise is this. This is how a clock would turn, right? 12, 1, 2, 3. So a clock will be turning in this direction. That's why this is the clockwise and this is the anti-clockwise. A person facing east turns anti-clockwise for 45 degrees. So this is the anti-clockwise. So the person would have turned 45 degrees and now is facing this direction. What is this direction? Northeast. Because I know this should be north, so he is between north and east, so northeast. And he walked for 2 kilometers, so he must have walked in this direction. So if a person is facing east and turned 135 degrees in clockwise direction, imagine this is facing east, this is 90 degrees, this is another 45. So a person in clockwise, this angle is 135 degrees. So this is the final direction he must be facing, which is southwest. So this is how the statement clues could be. Angles would be mentioned sometimes, to his right, to the left, clockwise, anti-clockwise. And sometimes the question would say man facing north now turns to east and walks. That's completely talking in the directions. So these basics are very important to understand, and then it's very easy to solve any direction sense question. Sometimes you get a question where you will be asked to find the final distance between the starting point and the end point. It's like a man facing north walks 3 kilometers. So a man, let's assume started here, facing north. I know this is the north, this is the east, this is the south, this is the west. Walks 3 kilometers. So let's assume he walked for 3 kilometers. He started at A, he walked up to B, and then he turned to his right. He still would be facing north. Now he turned to his right. That means he must be now facing this direction, that is to his east. He walks for another 2 kilometers. Let's assume this is another 2 kilometers. He reached point C and turns left. After reaching C, he would be still facing east. To the left of east is this direction, so he is turning into this direction. He walks for 4 kilometers. Let's assume he reached D. And now he takes a left turn before walking for another 2 kilometers. So he took a left turn, so he is facing north again. He took a left turn, so he would have turned this direction. And he walked another 2 kilometers. So he would have walked another 2 kilometers. That is his point E, and there is his final point. And now the question would ask how far is the person from his starting point. So this is the starting point, so you should draw a straight line joining both. Here it's super simple, it is turning out to be a simple straight line, which I already know this is 3 kilometers. What is this distance? 2 kilometers. Because, 4 kilometers, my bad. He walked 2 kilometers, then 4, and then 2, and then technically it's all 90 degrees, right? So this also must be, it's like a pair of parallel lines. So if this is 4, this must be 4, this is 2, and this is 2. So I know this part is 4 and I know this is already 3. So he would have walked 7 kilometers. The distance between the starting point and the ending point is 7 kilometers. This is a simple straight line. Sometimes we might have to use a Pythagoras theorem, triangular distance. I will show this with another example. A man facing north walks 3 kilometers turns to his right, and he walks for another 4 kilometers to reach his office. How far is his office from his initial point? So this is the distance, right? The straight line would be this. Now this is not a simple straight line to calculate, but I see a triangle here. I know this is 90 degrees. So A, B and office is a right angle triangle with 3 and 4 as the legs. So 3 square plus 4 square should be the office distance from the initial point, that is square root of 3 square plus 4 square. That's the Pythagoras theorem. So the distance is 5 kilometers from the initial point. So let's practice some problems using the concepts that we have discussed. As we always recommend, pause the video, give it a shot, and then continue watching this video. So we hope you have passed the video. So let's look at the question. So Janaki walks 4 kilometers straight from her house towards the west. So this is her house, and I know west is this direction, and she walks towards west for 4 kilometers. 4 kilometers. Now Janaki would be still facing this direction, and then she turns right. Right would be this. So she walks facing north now because she turned right, and walks for 5 kilometers. Point B. Thereafter she takes a left turn, so she would be facing north. Now she took a left turn, which would be this. Right would be this. So she took a left turn, which means she's again facing west, and walks for 6 kilometers. Further she turns left. She is now facing this direction. She again took a left turn, which would be this direction. This is the right and this is the left when she is facing the west. So she is now facing towards the south. She walks for another 7 kilometers. So I know this is 5, so she must be going beyond that point A. This whole distance is 7 kilometers. She finally turns right. Now she is facing this direction. She finally turns right. So the right of her will be this. So she turned right now. That means she is now again facing west. She walks for another 5 kilometers. And she reached this point. Let's assume this to be E. The question is simply asking in what direction she is now from her house. It's super simple, that she is facing west. Let's assume the question was also asking how far is she from her house. So this will look like this. So the distance is that from between E and the house. So I should be making a triangle like this. How much distance is this? I know this is 7 kilometers between C and D. So between B and A it's already 5 kilometers. So this will be 2 kilometers. So this would also be 2 kilometers. And CB, I need to find between D and this point. Again I split this into CB 6. So obviously till this point it should be 6 kilometers. And this is 4. So this will be automatically be 4. So it will be 10 kilometers on the whole. So it's simply a right angle triangle with 2 and 10 as the legs. So this will be square root of 104 kilometers. And this is how we should be solving the distance. A man starts walking from a point and walks 12 kilometers towards north. So this is point A and this is point B. Because I know this is the north. He is still facing the north after walking for 12 kilometers. He turns 90 degrees left. So this is left, and 90 degrees means he is turning in this direction, and walks a distance and stopped. And I don't know what is this distance. If the distance between the initial point and the final position is 13 kilometers, this is given to be 13 kilometers. How much distance he traveled after turning from the north? Right, I need to find this. So let's assume to be x. So again it's a right angle triangle because 90 degrees. He turns 90 degrees. So x square plus 12 square should be 13 square. So x square is 169 minus 144 is 25. So x is 5. So this must be 5 kilometers. Meera starts at a point T, walks straight to point U which is 4 feet away. Here you have to understand that they have not referred in which direction is Meera facing now. That means I can start from any direction and I should still be getting the same answer. So let me go ahead with the north direction. So Meera starts at point T, walks to point U, which is 4 feet away. She turns left, so she's facing north now. Now she turns left, that means she should be facing this direction, and walks to W, which is 4 feet away. And she is facing west direction now. She turns 90 degrees to right, which means she is turning in this direction. So she is again facing north. She is now walking 3 feet to go to point P. She turns 90 degrees right and walks another 1 feet. So she is now facing north. She turns right, that is in this direction. She walks for another 1 feet to Q. Turns left, she is facing this direction, so she is turning left, that means she should be now walking towards north again. Turns left at 90 and goes to V, which is 1 feet away. That means she walked for another 1 feet, and this is V. And once again turns 90 degrees right. Again she turns this direction because she will be facing this direction now. So 90 degrees to right, so she is now facing this direction and goes to O 3 feet away. So this is O, which is 3 feet away. What is the distance between T and O? If you observe this, I need to know if T and O are on the straight line. So that can be found out by this. T and U are on the same straight line. U and W are 4 feet away. If I find that P and O, that is this distance is also same, then I can count that T and O are on the same straight line. Which seems to be the case, right? Because this is 3, so this should also be 3. Because this is 3, this also must be 3, and this is 1, so the whole distance would be 4, which is equal to this. That means O and T are on the same straight line. So I need to find this distance, which is basically sum of this, which is 4, plus this is equal to this, which is 1. And what is the length of this? Equal to this, that is 3. So 3, so 1 plus 3 plus 4, that's 8 feet is the final answer for the distance between T and O. So that's it. Thank you for watching this video. If you're watching this video in the YouTube channel, do check out our full length course available for free at gtcube.com/store. Also do like our partners Facebook page, facebook.com/gtcube3. You'll get to see a lot of updates of various courses that would help you in your preparation. Thank you for watching this video, and let's meet in the next video.